Hello, my name is Mary Manna, and today I will be presenting the topic of growth hormones and antibiotic use in food production. Growth hormone and antibiotic use in foods. For over 30 years, farmers and food production facilities have been trying to use certain medications on their livestock. Veterinary drugs are for intended use for disease-controlling factors and growth promoters. What are growth hormones exactly? Using growth hormones, or noted as GH, promotes faster and bigger growth of animals. These growth hormones work at a cellular level, enabling the animal's body to signal more cells to be produced. This can potentially endanger the health of humans who consume these animals as meats. What is antibiotic resistance? Additionally, farmers are using unnecessary antibiotics in order to maintain the health of their already healthy livestock. This leads to antibiotic resistance in humans due to consumption through the food chain. Healthy animals may only receive antibiotics when a confirmed case is present within their barn. The implication by the World Health Organization lists antibiotics by importance to human health. The World Health Organization has an implication for the animal as well. The animal should have better vaccines, better hygiene, etc. to prevent disease. The United States regulation practices of medications for livestock, such as antibiotics and the growth hormones. The companies in charge of these regulations are food and agricultural organizations, as well as previously stated, the World Health Organization. Risk assessments. A risk assessment is an analysis of health effects regarding the human's vulnerability to danger in foods. Risk management. Risk management is to accept or establish alternatives to the risk. This is known as the political factor. Risk communication. Risk communication is to share knowledge and opinions based upon the risk with authorities, such as risk assessors and risk managers, etc. Growth hormones and antibiotic use in food production are harmful to humans. There are two perspectives on this. This topic is very controversial. First, we're going to dive into perspective 1, which is growth hormones and antibiotic use in food production are harmful to humans. People are becoming resistant to antibiotics and developing issues through antibiotic resistance. For example, vancomycin, which is an antibiotic, resistant Enterococcus VRE was seen to have antibiotic resistance in humans due to the overuse of antibiotic vancomycin in animal production. Growth promoter avoparcin contributes to VRE within the animals as well. This was seen through tested feces of these animals compared to animals without the growth promoter's feces. Growth hormones in humans, such as estradiol 17-beta, progesterone, testosterone, etc. listed, are being thrown out of the loop for humans from the growth hormone that animals are consuming. Growth hormones and antibiotic use in food production causes no threat to humans. So this is the opposite perspective of the one that we just previously reviewed. So, with that being perspective 2, growth hormones and antibiotic use in food production cause no threat to humans. Food is able to be produced faster due to these altered growth rates, leaving more food supply for the human population. Growth promoters, such as antimicrobial growth promoters, alters gut flora of the animal. However, no evidence of human harm was listed in this research. This second perspective is mainly viewed by business owners, such as the farmers, because this works in their benefit. Political, clinical, cultural, and social factors and forces shaping viewpoints and guidelines. This issue is controversial because farmers benefit from faster growth of their livestock so that they can make more money. To help illustrate this to you, I made up my own example. So, to exemplify, all 10 pigs on a farm are given antibiotics every day, along with the growth hormone. No pigs get sick, and they reach their full growth potential in a few months. This means that farm made more money off of all those 10 pigs that they were able to sell for meat. Now, on the other hand, 5 pigs develop disease that affects their ability to be eaten as food. 2 pigs are runs, leaving only 3 out of 10 pigs qualified to be consumed. This means that there is no profit or less of a profit for the farmer itself. However, this may result in more issues for humans consuming these medications that were given to their food. In 2019, antibiotic resistance led to 4.95 million deaths. That is a lot. Further, how does bacteria mutate regarding antibiotic resistance? Let's look at this through a clinical lens. The gut has its own developed microbiome of 300 different species of bacteria. This is known as good bacteria. Antibiotics are used against bad or too much bacteria in the body and works to kill off the bacteriophage. However, especially with frequent use of antibiotics, the bacteria's genes mutate, causing the bacteria to develop antimicrobial resistance genes. So now we're talking on the genetic level of the bacteria. Another clinical review of examples about how antibiotic resistance spreads. So for example, we start with itself, the antibiotic in the middle. The animal gets antibiotics and develops resistance bacteria in their guts. So this essentially transfers to the human because the animal ate the antibiotic, has the bacteria that's resistant to this antibiotic, and humans are consuming that. Especially with undercooked foods, this can be potentially very dangerous for humans. Humans need antibiotics to survive infection. Without antibiotics, there is a higher death rate from infection. This is why it's very important that antibiotic resistance gets controlled. Here I have a political view and a video that I thought was worthwhile to share with you.
So they roost in here. They only sleep in here. And then
Dana Key works for the United States Coast Guard, but you'll find her enjoying her other passions on her relatively small 2-acre farm in Pomfret, Maryland.
At this location, we do poultry and chickens and waterfowl. They're going to be for meat.
Key loves the animals on her farm and is working to one day expand her operation. But there's one thing she says she'll never do to increase production or to get a little extra money out of her animals.
I think that if you raise them right and you give them good food, clean water, sanitary conditions, you would never need antibiotics.
We know very accurately that we sell almost 30 million pounds of antibiotics to food animal producers each year in the United States.
Lance Price is a professor of environmental and occupational health at George Washington University and has spent years researching the effects of antibiotics in animal production on humans. His conclusion is that antibiotics should only be used on animals to treat illnesses, not for growth promotion, which he argues can cause antibiotic resistance.
When we feed those animals antibiotics, we're forcing the bacteria that exist in and on those animals to become resistant to the effects of those antibiotics. And a lot of those antibiotics are the same antibiotics that we use to treat infections in ourselves.
I think that there is an issue with human illness and resistance in human illness. The vast majority of that is unrelated to any animal use.
Liz Wagstrom works for the Pork Producers Council in Washington, D.C. and says there are times when antibiotics are critical to animal production.
If you've done everything you can to take good care of your pigs, there are times when antibiotics are a tool you need, and then they're appropriate, and that use is an appropriate and responsible use. Helps provide us with healthier animals that provide safer food.
Antibiotics have been used in food production for decades, but it hasn't been since 2008 when Congress added an amendment to the Animal Drug User Fee Act. Have we been able to trace exactly what's being pumped into our food?
And in those 3 years, we've seen a slight increase. But that's been 2009, 2010, and 2011. We've been using antibiotics since the 1950s.
The Animal Drug User Fee Act, or ADUFA, is up for reauthorization every 5 years. 2013 is the year for reauthorization, and advocates say now's the perfect time to require more data collection.
What are the animals that are getting the antibiotics? What are they given for? Are they given for treating the animals? Or how much is given to treat the animals? How much of it is given to get them to grow faster?
But others say additional amendments to ADUFA will only slow down a bill that was never meant to be about antibiotics in animal production.
Our stance is that ADUFA is not an antibiotic bill. ADUFA is a bill that helps FDA timely review applications for all animal drugs.
Antibiotic resistance in humans.
The FDA has admitted to concerns regarding antibiotics in animal production, like in this subcommittee on health hearing in 2010. But up until now, the FDA has only said it disapproves of using antibiotics for growth promotion.
There's this whole trust but verify, strategy. All we're doing is trusting.
We expect that the animal health manufacturers will stop producing and voluntarily give up labels for growth promotion.
As for Key, she says she'll continue to keep her animals in sanitary conditions, so she won't have to use antibiotics. For WashingtonExaminer.com, I'm Steve Doty.
With that video, we can see how this topic is so controversial. Now we will explore a socio-cultural view on this issue. On a positive socio-cultural standpoint, the growth hormone has intent of defeating hunger by providing more meat to individuals. The use of antibiotics for meat-raised animals has been completely banned in Europe, however, regulated in the United States. Sociocultural view. We know the United States process of regulating antibiotics and growth hormones for livestock. Let's delve deeper into European standpoints, specifically in Greece that I found a case study on. Greece has banned antibiotics and hormones regarding their meat-raised animals. Their society's norms or point of view on this matter is established by physicians rather than the government, which is seen in the United States. Participants in the study from Greece notated that they believe it is a severe danger to have easy access to these types of medications, specifically antibiotics. There were a lot of emotional feelings during this interview because Greek participants noted that human beings are human beings and their lives matter in its entirety. In my analysis, their viewpoint is to keep everyone 100% safe rather than good enough, as the United States perceives it. Socio-ecological context. Here, we can view how society and environments interact. Interventions were studied between high-income countries. It was stated that social media played a key role in spreading knowledge about antibiotic resistance from the foods we eat to society. However, based on government status, it was reported that there was a lack of diversity in interventions trying to fix the issue of antibiotic resistance from food. Socio-ecological context. This study advocates for better change of efforts to minimize the amount of antibiotic resistance and other toxins from foods detrimental to human health. Successive interventions needs severe improvement and implicated factors that support mutations of bacteriophage. A case study with E. coli examines the 42 interventions implicated by the government that provide failure or success of antimicrobial resistance. Improving quality of interventions to prevent AMR was implicated due to failure of testing government guidelines. Ethical considerations and action. Risk assessments and toxicology evaluations by veterinarians are made for animals to be consumed. Toxicology made sure levels of toxins are as low as possible before human consumption. Exposure and risk characterizations by the World Health Organization sees how well each drug metabolizes in the animal. Risk characterizations ensure there are no human health-related concerns or risks, but that does not mean none. Now on to ethics. Ethics of antibiotic resistance, type 1 ethical issue. Antibiotic and hormone use is documented as a type 1 ethical problem. A type 1 ethical problem, which is defined as no determined remedy for in regard to the issue. From a situational standpoint, there is no direct agreement on this ethical concern, which delays the FDA's regulation on this matter in the U.S. However, antibiotic resistance and hormones from our food are on its way to turn to a type 2 ethical problem. A type 2 ethical problem can be described as a known issue that society can violate agreement towards. From a situational standpoint, farmers may disregard regulations based on cost and what is cost efficient for them. Ethics of antibiotic resistance, agricultural ethics. Agricultural ethics combine public health and business ethics. However, tension with agricultural ethics are rising as business and health needs are not coinciding with each other. Agricultural ethics are being reevaluated in comparison to human rights. Agricultural farmers are upset due to higher health costs regarding animals and death rates of their livestock. Ethics of antibiotic resistance, a war. In order to bring more attention to this type 2 issue, it is advised consumers take action. Boycotting meat that was fed antibiotics and growth hormones. Reward farms with good tactics to keep animals naturally healthy. to advocate for the passing of the law known as Preservation of Antibiotics for Medical Treatment. Summary and conclusions. Many pieces of evidence show the human harms through consuming animals unnecessarily treated with antibiotics. Throws off the gut microbiome, allows for mutated bacteria to be resistant to needed antibiotic medications to treat infections or diseases. Hormones that animals are taking are interfering with human levels of hormones. Action is being assessed against this concern. There are benefits to this method of food production, however, health risks are outweighing the good. Thank you. Here are my references. I hope you all have a great day.